All right, today we are going to be talking about angle measure. So there are a couple terms that we need to know before we talk about angle measures. The first is a ray. Now we've talked about lines and we've talked about line segments. Remember, lines go on indefinitely in either direction. Line segments have an end. It has two endpoints. A ray is kind of a combination of the two. A ray is a piece of a line. One end has an endpoint while the other extends indefinitely. So we have one arrow on one side and then an endpoint on the other. An angle is formed when we have two non-collinear rays that share an endpoint. Remember, non-collinear means that they are not on the same line. So two different rays that are not on part of the same line that share an endpoint. So if you look at that example on the right, we have two rays, ray 1, which is blue, and ray 2, which is red, and they are meeting at an endpoint. That endpoint, we call that a vertex. So the endpoint of your two rays where they are meeting is called the vertex, and the combination of those three things, ray 1, ray 2, and your vertex, make an angle. Now, it's important for us to know how to name an angle in geometry. So we can use the vertex to name an angle. So for example, we could name that angle on the right just angle B. That's one way that we could name that angle, just using the vertex. Another way that we can name our angle is using the 3 points, 1 point on ray 1, 1 point on ray 2, and then our vertex. But the important part is that your vertex always needs to be the second point listed. It always needs to be the middle point that is listed. So for the example on the right, we could name that angle CBA or ABC, because B needs to be in the middle. We cannot name it angle BAC or angle BCA, because B needs to be in the middle since it is our vertex. So let's look at this angle. We have 3 different ways that we can name this angle. Remember, one of them is with your vertex, so we can name this angle Y. The other 2 ways are using the 3 letters. Just remember that your vertex needs to be in the middle. So we can name this XYZ, or we could name this ZYX. In our angles, we also want to talk about points that are inside and outside of them. We have points that are called the interior of an angle, and that is going to be any points that are inside your 2 rays of your angle. So interior means inside. So it's a point inside those 2 rays. And exterior of the angle is any points that is outside of those 2 rays. So on the outside, exterior. So an example of an interior point would be point X, because X is on the inside of our 2 rays. It is between the 2 rays. An exterior point would be point Z, because Z is outside of those 2 rays. We're also going to talk about a couple different types of angles. One of them is a right angle. A right angle is always 90 degrees. So right angles are always 90 degrees. An acute angle is always less than 90 degrees. So any angle that is less than 90 degrees, it could be 5 degrees, it could be 35 degrees, could be 89 degrees. If it is less than 90, it is considered acute. An obtuse angle is an angle that is more than 90 degrees. So that could be 91 degrees. That could be 150. If it is more than 90, then it's considered obtuse. And then a straight angle, we also call that a straight line, is always 180 degrees. A straight angle which is the same thing as a straight line, is always 180 degrees. So if we look at the example below, the first example is acute because 62 is less than 90. The second example is right because it is exactly 90 degrees. And your third example is obtuse because it is 135 degrees, which is greater than 90 degrees. So let's label these. Our first one is 90 degrees, so we know that it is a right angle. If it's 90, it is always right. 60 degrees is less than 90, so that is going to be acute. Same thing with 45 degrees and 30 degrees. Those numbers are all less than 90 degrees. And down at the bottom, 120 is greater than 90, so that's going to be obtuse. And same with 150, that is greater than 90, so it is also going to be obtuse. Now we're going to talk about angle bisectors. The word bisector you'll see again in geometry. Bisect means splitting something into two equal pieces. We'll also say two congruent pieces. Congruent just means equal. So an angle bisector is a ray that divides your angle into two congruent or two equal angles. So in this case, that ray KM, that red ray in the middle, is splitting our angle into two equal angles, angle LKM and angle MKJ. So bisect means splitting into two equal pieces. So we're going to use some examples using that knowledge of angle bisectors. So if OC is the angle bisector of our angle AOB, and AOC is 42 degrees, I'm going to label this 42 degrees. What is AOB? What is my entire angle here? Well, now we know by the definition of an angle bisector that if AOC is 40 degrees, COB also has to be 42 degrees. So to find AOB, we just need to add those two together to find the entire angle. Remember, piece plus piece equals the whole. We add those two pieces together. We get that the entire angle is 84 degrees. We're going to do something similar here. It says if OC is the angle bisector of AOB, if AOB, my entire angle, is 64 degrees, what is the measure of angle AOC? Now this time I gave you the entire angle, but we know by the definition of the angle bisector that we're splitting it into two equal pieces. So that means we are going to be taking this 64 degrees and splitting it into two equal pieces or dividing it into two equal pieces. And 64 divided by 2 is 32 degrees. So we know that angle AOC has to be 32 degrees if 64 is being split into two equal pieces. Our final problem for today says if OC is the angle bisector of AOB, AOC is 4x plus 9, and COB is 7x plus 3. What is x? Now we know by the definition of an angle bisector that those two angles have to be equal to each other. AOC has to equal COB, so we can set up a problem where these two are equal. And we're going to solve. We want to get our x's together, so I'm going to start by subtracting 4x from both sides so that I have both of my x's on the right side. 7x minus 4x is 3x. And this looks like a traditional two-step equation. We are then going to subtract 3 from both sides. 9 minus 3 is 6. And then divide 3 from both sides. 6 divided by 3 is 2. So x has to be equal to 2 in this problem.